Welcome all to the Swedish Pavilion again, where we are sending live from the UN Climate Conference COP28 in Dubai. Welcome everyone here on site and you joining us online. Over the 2 COP weeks, the Swedish Pavilion hosts over 60 live-streamed seminars and countless of roundtables, bilateral meetings and network events. We've gathered world-leading interconnecting stakeholders from the public and private sector, academia and civil society to present existing innovations that are scalable here and now, present concrete actions to scale the solutions and mobilize stakeholders and resources to turn the NDC NAPs into reality. This seminar will focus on circularity, material independence in the energy sector. We will hear from experts and business leaders at the global frontline that will discuss how far can we reach with modern sorting to maximize the circularity, to reuse materials to a larger extent, how we can make use of the waste that cannot and should not be circulated, and if waste incineration with carbon capture and usage or storage could be a solution. My name is Alexis, Global Sustainability Team here at Business Sweden, and we will have the honor to moderate the session and guide you through the insights and discussions. Without further ado, I would like to invite you to welcome our first speaker to give a brief presentation on Europe's energy use and its challenges. Please give a warm welcome to Thomas Spencer, Senior Power Sector Modeler and the lead author of the World Energy Outlook at the International Energy Agency. Welcome, Thomas.
Thank you very much, Alexis, for the very kind introduction, and thank you to the Swedish Pavilion for the invitation. The International Energy Agency is delighted to be here. So what I will do in the very short time that has been allotted is to try and give you a sense of where Europe stands on energy security and the importance of reducing our imports of fossil fuels for European energy security. So if we look at what happened last year, Europe and the world faced a quite extraordinary energy shock. In the IEA's assessment, this was the first global energy shock, even more significant than the oil shocks of 1973 and 1979, because it affected all fuels and all countries. So if we look at the oil price, it spiked above $125 per barrel. Natural gas price spiked at 10 times the historical level. Some countries were unfortunately priced out of the market, were not able to afford their imports. This natural gas price is equivalent in energy terms to $200 per barrel of oil, okay? So quite extraordinary evolution that we saw in natural gas markets. But it also affected coal markets, with countries that import coal like India in Southeast Asia facing prices that were as much as 4 times their historical level. So a quite extraordinary energy shock that caused, a synchronized inflationary upswing around the world, led to a huge redistribution of economic resources around the world. We estimated that last year, fossil fuel producing countries earned about $4.5 trillion in revenues. So extremely significant amounts of money. And obviously this had an impact on Europe's economy and on Europe's society. The good news is that if we look at indicators for European energy security, we do see improvement. So this is our projections under current policies of European demand for oil, natural gas, coal, European electricity generation, investment in energy, and CO2 emissions. And you can see that under current policies, we project that things will be moving in the right direction. Oil, coal, and natural gas demand will be falling. We see that last year and the COVID pandemic led to a huge increase in Europe in investment in energy, and particularly investment in clean energy. So solar PV, wind, heat pumps, retrofits, electric vehicles, and that will start to pay dividends in the years to come as these investments lead to increased uptake of clean energy technologies. But the last thing that I would like to highlight is that If we look at what Europe has promised to achieve in terms of emission reductions to 2030 and to 2050, we don't quite see Europe there under current policies. If we strengthened action to achieve current policies, current emission reduction pledges, we would see an even sharper reduction in fossil fuel demand, even larger increase in electricity demand because you would electrify more of the economy, a ramp up in energy investments because we would need a lot more capital into spending on clean energy investments, and of course CO2 emissions going down to reach net zero by 2050. So the key message here is Europe is on the right track, things are moving in the right direction, but we still need stronger policies and stronger actions to achieve our goals, both for CO2 reduction, but also for more energy independence. If I turn now specifically to natural gas, this is natural gas demand in the EU. In 2022, it was about 350 billion cubic meters. That's already down 55 billion cubic meters on 2021 because of the gas-saving measures that were achieved. If we look at where our ambitious policies would get us for the European Union to achieve its 2030 target, we would see natural gas demand falling to about 250 billion cubic meters by 2030, largely because of substitution of natural gas in the electricity sector through renewables. In the longer term, as we move towards net zero by 2050 in the European Union, we see even bigger reductions in gas demand and more sectors starting to play a role. So reduction of gas demand through electrification of the building sector with heat pumps is absolutely critical, but also retrofits of the building stock, substitution of gas demand in industry. That orange bar is other, and that includes measures like what we call avoided demand at the IEA, which is circularity, making sure that we use less materials, that we recycle the materials that we use. If we look at what this means for imports, again, starting on the left, in 2022, Europe imported most of its gas demand, and you can see the huge red wedge, which is spot market imports as Europe turned away from pipeline imports from Russia. Going forward, we project that the import demand will reduce by 2030 under current policies, but if we can implement our 2030 target, we can cut our import demand down to the level of this yellow hashed bar, so approaching only 270 billion cubic meters. And if we can get down to net zero by 2050, then our import demand would fall to significantly less than 50 billion cubic meters by 2050. So the key message here is Europe can't be complacent. We will still have substantial import needs by 2030. We can reduce those import needs by fully implementing our climate targets, but there will still be a need for imports. In the very long term, to 2050, if we can get to our net zero by 2050 target, Europe's import needs would be substantially reduced and energy security improved. So with that, I'll stop and thank the organizers again for the invitation. Thank you very much.
Thank you very much, Thomas. Thank you very much indeed for this very insightful presentation and ground floor for, of course, discussions upcoming. And we'll, of course, get back to you. Joining us online is Robert Westerdahl. If we have Robert joining us. Can you hear us, Robert?
I can hear you very well.
Perfect. Glad we're having you. Robert is a partner at McKinsey & Company and co-founder of Material Economics. Robert, glad to have you. The floor is yours.
Thank you very much. So I'm here to talk about plastics and material system, and as that is, of course, very much connected also to our greenhouse gas emissions that we just heard about. So if you actually move to the first slide, just to give the context, and also just to let you know, so material economics is now a part of McKinsey, and we focus on circularity and on basically how we can build more sustainable materials flows to reduce CO2 emissions, but also improve other environmental factors connected with our materials use. And especially for the energy system in Europe, it is very interesting to look at our use of plastics, since a lot of that is used also in the energy system. And if we look at a bit of the history, we basically, since the 70s, grown our use of plastics, so basically how much plastics is reaching end of life, by about 450% since 1970. And globally, about between kind of 4 to 6% of the global greenhouse gas emissions come from the production and incineration of plastic. That's both production and incineration. And the key, I would say, kind of issue with plastics is not only that it takes a lot of energy to produce, but it also, we basically embed a lot of fossil carbon inside all of the plastics molecules that end up in most products in our everyday life. But then coming from that, where we're seeing kind of a tremendous increase of the use of plastics, we are seeing now a lot of activity on increasing both the use of recycled content, so basically reusing plastic, but also a lot of companies that are very heavy users of plastic to basically set more and more ambitious targets on reducing their total greenhouse gas footprint across the value chain, where then plastics is a very big, very important part of the solution. I think that is the context. It is a growing challenge, but there is also a lot of kind of opportunities and changes that many companies and countries and organizations are targeting. If you take next slide, just a very quick word on where do we actually use plastic. So this is our modeling on where does plastic come from, and where do kind of all of the big end-of-life flows end up. So basically we have packaging being the majority of our plastics. So that's basically the plastics used for packaging in almost everyday product, kind of everything from consumer products to packaging in business-to-business supply chains and so on. So plastics is, of course, a very versatile material, and therefore it is used very heavily across the whole packaging sector. But also in buildings, we use a lot of packaging, or sorry, not packaging, plastics, in basically different components in buildings, in pipes, and so on, as it is also a very durable material where we can avoid a lot of the challenges with other called bio-based materials. And then automotive sector is also a very big use of plastics, where we use a lot of the automotive components from plastic. So those are the main, well, the user segments, and where we see also the biggest end-of-life flows. But then if we take the next slide, also what actually happens with this plastic, and this is a focus view on Europe. And we estimate that about 45 million tons of plastics end up as it's called end-of-life plastic. So in products, in packaging that is thrown away, and so on, every year. That is actually a significantly higher number than what sometimes is seen, because what is usually calculated is what we call here the collected end-of-life plastics. But what we see is that there is a lot of plastics that reach end of life that is not collected. It is mixed in different waste streams. It is plastic that is left in the ground or left in vehicles that are not taken care of. So there's a big chunk of plastic that actually does not reach the recycling system. So there we lose about 15 million tons. And then out of the 30 million tons that actually end up in the waste management system, we have about 7 million tons that go into landfill, about 12 million tons that end up in energy recovery. So basically as a fuel for producing heat and electricity. And about 10 million tons that actually end up for recycling. And then we have a big export of plastics that is not being recycled in Europe. And then we have a number of process losses when the plastic that is sent for recycling is managed. So there we basically have only about 6 million tons in the end that is actually recycled for new plastics materials, which is then actually a factor of about 13% out of the total end-of-life plastics. So this is, of course, a huge loss in the potential in how much plastics we could actually reuse, and also when coming back to the challenge of reducing and committing to our net zero targets. Out of these 4 to 6% of global emissions, we're actually only circulating about 13%. And if we also take an economic perspective on that, if we can take the next slide, we also translated these numbers into what is the economic value of the original plastic and what happens with that economic value. So basically, what it turns out is that about 62 billion euros in original value of the plastics is used in the economy. Out of that, we lose about 49 billion euros in material value because it has not been recycled for new materials. There is, of course, partly an energy value in incinerating this, but that energy value is much, much lower than the original value of the material. And then only about 13 billion worth of material is sent for recycling. But in a recycling system, we also have, so we often talk about plastics, but it's actually many, many, many different polymers. We mix those, and it's usually very hard to get high quality plastics out of that. And therefore, we also have a lot of price losses due to the value of recycled plastics being much lower to primary plastics, as we can use it in much fewer applications due to lower quality, worse aesthetic, and so on. And then we basically end up with a view saying that out of our total recycling of plastics, we actually have only about 7 billion euro worth of recycled plastics when starting from 62 billion euros. In that sense, also, we are very far from a economic circularity when it comes to plastic. But at the same time, we're seeing that this is changing now very rapidly. If you take the next slide, we have seen a lot of companies making very, very ambitious commitments on increasing their use of recycled plastic. So these are a number of the big users of plastics packaging that have made commitments on rapidly increasing their use of recycled plastic in their packaging. And if we look at what that means in scaling up actually the use of recycled plastic in packaging, and so the recycled content in packaging, you see that we have had about 2 percentage points per annum increase over the last 5 years. And now actually we'll need to go up to a 5 percentage points increase per annum. And what this actually means is also that, of course, the quality of recycled plastics need to increase significantly, or we need to find other sources to basically create the recycled plastics from than what we are doing today in our waste management systems. This is, of course, a super important topic, and we also see that policymakers in the EU are also onto this topic very ambitiously. So if you turn to the next slide, we've just listed a couple of the important policies pushing for more and more circular systems. And here you see, for example, the plastic recycled content, that having the ambition to increase that from about 13% in 2020 up to 50%, of course, being a very big challenge, but also increasing how much of packaging we are recycling, even though, as I just showed, even though we are recycling today, it's not necessarily so that it ends up as perfectly recycled material that can be reused again. But that is at least a very good symbolic push for increasing the recycled, the recycling of packaging. And then we need to also ensure, of course, it is high quality recycling in the end. So if you go to the next slide, I can just summarize very quickly. So basically what we're seeing, a very big challenge in front of us, at the same time, a lot of activity to increase circularity of plastic. And here I see it's really a diverse set of solutions that are needed. It is around how do we improve the quality of recycled plastics? How do we ensure that we can capture some of the fossil CO2 molecules from incineration so that we can also reuse those as new plastic feedstock? How can we increase the use of recycled plastics in producing new plastics, but how can we also increase the use of renewable carbon in our new plastics across Europe, so that we can basically both meet the plastic challenge at the same time as meeting our climate target. It's a big opportunity, but also a big challenge in front of us. Thank you.
Thank you very much, Robert. Thank you very much. Presentation with great ambition, but still a gloomy picture indeed. I would like now to open the floor to our panelists. I will ask, of course, Thomas to come back, but also please welcome Henrik Tegner, EVP and Head of Strategy and Sustainability at AFRY, welcome, and Cornelia Mulder, Sustainability Expert at Stockholm Exergi, the Stockholm's energy company. Welcome you all. Thanks for joining us. Henrik will give the first shot with you.
Sure.
Please. Could you give us today some concrete examples of how you at AFRY work with circularity and how to increase resource efficiency, recycling of plastics, of course, recycling of textiles. What are the opportunities and what are the challenges that you face today at AFRY?
Thank you very much. So great presentations from both of you. I think it's very inspiring and insightful, and I think it will be good for our discussion now. So thank you. So AFRY, I mean, we're an engineering design company, so we work a lot with all the way from the feasibility study to the design and engineering and help to build solutions like recycling solutions for plastics or, for that matter, waste to energy plants. But I think to start with, I mean, circularity is quite a complex topic, obviously. Now we talked here specifically about the recycling of plastic, which is kind of one little part of closing the circular loops. And I think that there are a lot of things that need to happen. You often say that about 70% of the sustainability of a product is decided at the design stage of the product. So it's quite a lot about how you design things for more circularity. And then we heard here a lot about the value of the materials. And I think that to be able to increase the value of non-virgin materials is very important, or make virgin materials more expensive for that matter. And then, of course, we have the technical solutions that need to become better and better. So I was thinking I could give two concrete examples. So one example is on plastics. And I think it connects very well to what we heard Robert talk about here, because he mentioned that 13% of plastics is recycled today. We're working concretely then with a German company called APK. So we're implementing with them a new technology called new cycling. And the idea of this is to be able to use more types of plastic flows, because we know that, as we heard, plastic is very diverse. Even if it is plastics, there's so many types of plastics, and they need to be treated differently in the recycling process. And so we use many material flows, and we're also able to mechanically produce granulates of plastics. So not by repolymerizing, but to create granulates. So use less energy and also make them to nearly the same properties as virgin materials. So to really increase this small share at the end that was able to use, and to not have the big loss of value of the recycled material. I think this is super important, interesting project. Of course, it is only one, and you just can see the volumes. We need a lot of these type of projects in order to get to the solution. But I think this is one example that the engineering solutions are now starting to exist also in this field. We need to continue to implement them. We need to continue to get the cost down and get the speed of implementation up. Second example I'd like to discuss briefly is then moving away from plastics and onto textiles. So we know textile fibers. I don't know if you followed the debate in Sweden lately. There's been a lot of discussion about collection of used clothes for recycling, and they apparently ended up in very strange parts of the world instead of being recycled, right? So we know that this is a very complex question as well. But so here I would like to highlight two different things, because one is that the recycling of cotton is possible, but it is still not a very well-developed process. But this is where one example of where we're working in order to make this process more efficient, release less microparticles, use less energy, and get a better quality output of the recycled cotton product. But the other option to make the clothing industry flow circular is to not use cotton, but rather use cellulosic fibers, which we like in the Nordics because we have so much trees and good sources of material. So that is another project where we're working now to concretely build factories for use of cellulosic fibers. And of course, you might have had some garments of cellulosic fibers in your life, and at the start they were maybe not so good. The properties were not so nice maybe to wear, but that is also becoming now much better and better. And I think make it better, make it cheaper as one alternative. I don't think we can replace all cotton by cellulosic fibers, but we need to use the different options to make it more circular. So those would be my two examples of concrete recycling. We will talk tomorrow about recycle of phosphor, for example, which I think is another very interesting topic, but we can save that for tomorrow.
Indeed, thank you very much, Henrik. Cornelia, over to you. I have two questions, actually, but linked. How does today Stockholm Exergi, as waste managers with incineration, foresee your future role in both the resource and energy systems? And linked to this, how does Stockholm Exergi work today to increase resources efficiency? And what concrete changes do you see as necessary steps going forward? Thank you.
I will try to answer your questions. Firstly, we've designed our energy system to take care of residuals from society. And every year we distribute about 10 terawatt hours of heat to Stockholm. And that make about 3 terawatt hours of electricity available. And therefore it can also be part of the green energy transition. And one of the residuals that we use from society is residual waste from households and from different kinds of industries. And we only want to take care of the actual waste. And when I say the actual waste, I mean that everything that can be reused or recycled should be. However, about half of the residual waste that we receive from households today is food waste and different kind of packaging that should be able to be recycled. And think about it, if that would be recycled, the household residual waste would decrease to half. And that would also mean that we could treat residual waste from the double amount of people. And so far, when treating waste, we're able to immobilize hazardous substances and, of course, generate heat and electricity. And we also have a mechanical sorting facility as a complement to the sorting done at people's home to increase the sorting of plastics and metal. But going forward, we see that carbon capture is a must for waste incineration. And the carbon that we capture can be either permanently stored or it can be utilized. And if it's utilized, I think we can say that we become a last sorting step. We can sort out the carbon and it can be reused in different products. But with that said, we only want the carbon that cannot be recycled in a more resource-efficient ways, like the ways that Henrik talked about. So maybe I can say that you, Henrik, can pick the raisins out of the cake, and we take the rest. Thank you.
Sounds excellent collaboration there. Thank you. For our next questions, more open to our panelists here. Starting with the negative, what is currently, in your perception, blocking or hindering the circularity systems that exist today? Who wants to take it?
Yeah. We try to build a little bit on each other, but because I think there are lots of blockers, and as I said a little bit before, I think that the design is one really important. You know, how do you design for circularity? And I think that's where a lot of things start, both in how you combine things into a product, but also the materials that you select for the products to make them as recyclable as possible. Then I think that we have. We mentioned here companies setting targets previously on how much recycled content to use, and I think that is very good, and I guess that is also a result of the policy that is being pushed into. So legislation and policy, I think, is really important to show the direction that we as a society, we want to have more circular flows. I think that will lead companies to set in the end target. So and lacking legislation, I think, is also sometimes allowing the use of recycled materials into new products. I know we will talk about that tomorrow with the Ragn-Sells regarding phosphorus, for example, which is one challenge. And I know that challenge exists in other cases. We have been working on construction materials. Construction materials is one of the largest waste flows. And there it's quite complicated to be allowed to use old construction material into new buildings. And you maybe don't even know what it is, right? Then I think that the pricing is important. We know that we have a lot of fossil fuel subsidies still. So, you know, if we continue to do that, it will be in many cases cheaper to use virgin fossil fuels than recycled materials. So I think the whole cost pricing is also a blocker. It's too cheap, and we saw that a lot when all these graphs that Robert were showing on the price hikes when it was much more difficult to get virgin metals, for example. We looked for new ways of getting them from mine waste instead of getting new ones.
I agree with what Henrik said, but I want to start from the beginning, and I think a key word is resource sufficiency and not only resource efficiency, because we know that circular systems is key to become fossil free, even in the material world. But how big this circular system should be is also important. So today they are enormous, but maybe they can be smaller. We should use materials, but in a sufficient way. And to continue on what you said, Henrik, about the pricing, it's really interesting that the chemical industry in Europe are within the EU ETS system, but they're still getting more. They are still allowed to release a lot of carbon dioxide for free, which also makes the pricing of plastics not very good.
So one of the sort of subsidies for fossil fuels, yeah.
Excellent, thank you very much. Before my next question, maybe we can bring back Robert here on the screen. Might be great. On the positive note then, what are the solutions? What concrete actions are needed to close the loop and create new value chains? Anyone?
Yeah, yes. So I think of this in two different ways. So one is, of course, what private companies can do. One is what society can do. And if we start with private companies, I work with a lot of clients that are big users of plastics, either inside their product or have very significant packaging flows. And they, of course, when having their very ambitious targets on reducing their value chain emissions, which is then where plastics is one important part. Recycled plastics is one often it's called lower cost alternative, but the problem is access. So access to high quality recycled plastics so that they can actually replace some of the primary content. And what they need to do is really how do they secure that access and the reliable supply of recycled plastics? And so we see a lot of companies taking action in that area to basically secure either their own end-of-life product or other end-of-life flows of plastics that they can then plug into their own supply chains to basically secure access and a privileged access to recycled plastics materials of high quality and also stable supply. As that is, of course, super important for any large production process where you don't only need the right quality, but you also need the right amount at the right time during the year, and you need predictability. So there we are seeing a lot of movements across all of Europe with many different clients I'm working with. Then also from a societal perspective, recognizing, of course, the important role of plastics in reducing our CO2 emissions, it is very important also how to create incentives to make sure that we, one, reduce the total CO2 for producing plastic, but also reduce the CO2 from end-of-life plastic. And both of those can be addressed, of course, from partly setting a price on emitting CO2 in the first production of plastics, but also making sure that there is a price that creates incentives to reduce the release of fossil carbon from incinerating or treating end-of-life plastics. That is, of course, that can, of course, create then a very clear incentive to have more carbon capture and then either reuse to make sure that it can enter into the carbon flow for new plastics, or that it can go into the ground and be stored and not released into the atmosphere, but also using more renewable feedstock, so from cellulosic fibers or other renewable sources to have actually renewable carbon atoms that go into plastics from the first stage. That has been much more expensive so far than using fossil feedstock for the plastic production. Therefore, of course, it had to be an incentive as well to make sure that we are using less fossil and more renewable carbon that goes into our plastics production. And that is, I would say, very much of the role from society. And then we also have, of course, how do we build a efficient reverse logistics system to make sure that we collect and we sort and we separate the plastic streams so that we can also support very good entrepreneurs on doing high quality recycling, but they also need a good feedstock to be able to do that. And right now we are mixing plastics in very many different ways and makes it very hard to actually recycle in a high quality way.
Thank you, Robert. I'm being told the time runs. I'm so sorry about those, short interactions. I want, before, of course, coming back, some questions for Kenya, Enrique, and Robert. I want also to give the floor a bit to Thomas. Thomas, on a more maybe macro perspective, what concrete solution exists, according to you, to increase the security of supply in Europe today?
So, first of all, the conversation that is being had here about plastic and wastes, this is not something that is separate from the conversation about energy transition. So if you look at the global energy demand today, about 15% of the demand for energy commodities and fuels is actually not used for energy at all. It's a feedstock into, in particular, petrochemicals production. And in the IEA modeling, anything that we can do to reduce demand for these products, so Cornelia talked about sufficiency, or to increase recycling, that will ultimately reduce demand for the fossil fuel inputs. And so in our modeling, we look at circularity of materials as a key measure for the energy transition. So I just wanted to make that connection. The second thing is that, of course, in Europe, we have many other things that we need to do. In the near term, we can substitute natural gas use in power generation through the deployment of renewables. We can start to substitute it in the building stock through the deployment of heat pumps, but also district heating in countries that have district heating systems established or can set them up in urban settings. And again, the more that we can do on the energy transition side, the more that this would lower input costs, increase security supply on the materials side. So these things are things that go hand in hand. Just a final word on, particular technology that the IEA looks at with a lot of promise in contexts like Europe is heat pumps in the building sector. Heat pumps are an extraordinary technology. They basically recycle waste heat from outside and concentrate it and bring it into your house with an efficiency that is 4 to 5 times more than a gas boiler. And so if we're looking at displacing gas in the building sector, of course we need retrofits of the building stock. It's very difficult. We know that. About 1% of the building stock in Europe is retrofit every year. Even less is retrofit to a deep level with high energy savings. So we need to enhance that. But we also need to start deploying technologies like heat pumps in the building sector. But my key message is these two go together and they can support each other.
Thank you very much, Thomas. We're running out of time, but I still want to hear a quick comment from all you four. Phasing out from fossil fuel, that's the main topic, of course, we know from this COP. Should it be from the energy system perspective, Thomas, or products, Enrique and Cornelia, Robert? Quick comment on this one, and then we will need, of course, to wrap up, unfortunately, but please. Who wants to give a go?
I'll start. Firstly, I want to say that I don't think there should be opposition between material recycling and energy, waste to energy. I think we can all do what we're best at, and in the northern part of Europe, where we have a high heat demand, district heating is a good solution, and then we can also take care of the rest from the society. And hopefully that's a very small part of the materials that we use. And secondly, we're creating new businesses when we're capturing the carbon, and hopefully we can utilize it. And for this, we need new collaboration and business partners. So here I'm bringing out a hand. Thank you.
I think your question is phase out of fossil fuels, okay? That needs to happen in energy and in products. I think that it is technically much easier to phase it out in energy. I think that plastics is an extraordinary material where we need to find ways to recycle, reuse as much as possible, and also find alternative ways to make plastic. But I think we will have a much harder time to find a good replacement for plastics in all these applications. Because for energy there are lots and lots of solutions for not using fossil fuels, and they are available already today at scale. No more research needed. So let's start with that, and then we take the others as we go. Of course, packaging 25%, that's a little bit shocking. There are quite good examples, alternatives. You don't need plastics for that, right? But in general, for sure, energy. Go.
I would agree with Henrik. In our modeling, in a net zero emissions scenario, a lot of the residual demand for fossil fuels is as a input into plastics production. Of course, as I mentioned, anything that products can do to reduce demand helps on the energy side, and anything energy can do to reduce demand helps on the product side. So these are not oppositions for sure.
Robert, final word for you, and then we need to wrap up this one.
Yes. No. So I would say that they are both very important, and we need to recognize that they are interconnected. So as we said, of course, renewables and getting rid of fossil carbon in the energy system, I would say, is relatively easier. But if we do not manage to build a much more circular system of materials, we will need much, much more energy to decarbonize. And that, I think, is the big challenge. So we need to look at them interconnected, and we need to succeed on both fronts.
Thank you very much, Robert. I would like to thank you all three, Thomas, Enrique, Robert, Cornelia. Thank you very much. Warm applause. Thank you so much. And I would like to thank you all for attending today, the panel, all the attendees as well, the attendees online. Please follow us on our page, and please visit the Swedish pavilion, of course. As we used to say at the end of our sessions, and we believe in it, the time is now. The race is on, and together let's pioneer the possible. Thank you very much.